Hello everyone, welcome back. In this part of the video, we will actually be making a very small adjustment to our previous setting out. I should have actually included this, but after having some thought about it, I thought I might just make a new video out of it and make it short, hopefully, so that we can focus on building the actual geometry in the video after this one. So the adjustment that I want to do with our setting out is, remember previously we've ended up with our main columns here, which is totally fine. And that one was generated from our main setting out, which you can see highlighted in green here. And this part of setting out, it actually includes a straight section on both sides. And truth of the matter is we don't actually need that straight section in order to create these columns. This straight section is what I'm talking about. We don't actually need it for the main column, but we do need those straight sections for the secondary columns that you will be making, that are going to be in this one and something like that. And there will be like a few here, and then here there's going to be like this. Because if you look at a reference folder, a reference pictures example, let's take a look at this one. Yeah, let's let it cycle a bit. See this column here? That one stayed the same because it's actually within that straight section that we were talking about. The same goes for the other side. But look at the column that's next to it. That's this one, for example. You see that it changed. That is because it begins to follow a different contour. So with that said, you can actually say the first column, okay, is the only column that is going to be the same throughout. And you can actually see that in all the other pictures. For example, if I switch to this one, for example, you can see if I were to draw a line. Let's draw a line, doesn't have to be too thick. So this is a column that I'm talking about. You see that it actually aligns all the way, while the second one here, that one doesn't. So with that said, we want to modify our initial main column, or the initial main setting out line, in order to incorporate that. To cut it short, we have our main setting out arc here, and what we want to do is we want to cut off the straight section from this part, meaning we cut off this one from the overall, and then we put it into that curve into one package. So this is actually one package, and this can stay as it is. So that's the adjustment that we want to do, and then after that we're going to make our setting out for these curves. We will prepare the setting out of that curve for our next part. So with that said, I hope you understand that, and let's do the adjustment now. Okay, so I can see that this one actually hails from this one, which is the extend curve that extends the original curve. So it's, you might think it's easy as, okay, then let's just connect this one to here. Yes, that's the first step, but it will break a lot of stuff, as you can see. And that is because our columns actually depends on a continuous curve. And if I were to enable our continuous curve, well, it's not continuous. It's broken. We are now missing that link. That's because we yet to include that straight section into our secondary arc setting out. So let's do that now. We know it comes from this one. So what I suggest we do is we shatter it from this point using points from our original. So that's actually, let me make this into a default color for now so that I can easily group it. Let me temporarily delete the group, and then we can use points on this one as parameter to shatter the curve that we got here. Okay, so let's do shatter. We want to shatter these curve, and the way we want to shatter is I first need, let's get the endpoints from our initial curve. what I'm gonna do, because I know I will only be needing endpoints, so I'm gonna set this to reparameterize so that I know 0 is gonna be the start and 1 is gonna be the end. You can actually put in a panel here if you like, in this way, if that is something more visually clear for you, which actually just do that. Make a script a bit more readable. So we know what we're doing here. So we have our endpoints. Obviously, we need to graph this part because we want both points to be applied to each curve. So once we've done that, we might need to do something with our tree structure, but let's leave that for later. So now that we have that, okay, let's have a look at our tree structure. We might need to graph this one too, because if I simplify our tree structure and I do a param viewer on top of this, you see that we have 6 branches. The first level, the branch, the number here dictates which block it is. The second dictates the each individual section. So for the first one, we should have 0, 1, 2, 3 because we have 3 wings, and the second 2, and the last one 1. So we need to have the same one for our shattering. As easy as just right-clicking on the C and graph that one too. And now I can say is, since I need a parameter, I'm going to use a point closest to curve in order to generate the T here. The point is obviously going to be our endpoints. The curve is going to be that one. And we will also graph this one too in order to make it match. So now, if I simplify this, we should have the same data structure that we can use to shatter our curve. So if I were to disable that, and now I have this. So what I can do here, I need to filter out the straight section, right? Let's see, what can I do? Well, I can do a sort length. I think that will be the easiest to do, because in no case will our straight section be longer. Actually, it might, but given the parameters that we set here, it will not be longer. Actually, it will never be longer. So we're using a sort by length in order to filter out the short curves, or filter out the long curves and select only the short curve, which are the straight sections. So I guess if I were to do, let's do a culling on the index. Since we want to call the last one, we want to reverse this and call it at 0. Because once it reverses, it means the longest is now at the beginning. So now if you select it, you see the green highlighted for our straight sections. And now we need to find a way. Let's turn on a param viewer again, which is this one. So we need to find a way in order to make this data match. Actually, let me pull this down just a little bit right there. And then we can pull this all the way up here, because we need to merge this in this one anyway. So let's simplify this in order to give us a better look. Okay, by the look of it, it seems like if we only trim the tree by one level, and the reason I'm saying this is because if you look at the data structure from the actual secondary curve, the branches only extend to one level, which is the root. So once we trim that, we should have that matched. And when you have that match, you can easily take another, what do you call this, the merge, and it will merge according to their same data structure. So this is after the merge. I have 3, 2, 1, and before the merge, sorry. And after the merge, I expect the 6 to be added to the 3, 4 added to the 4, 2 added to the 1. So we will have 9, 6, and 3 in the end. And there we go. So that part is done for us. And now you can see, if you hadn't seen that, let's remove this once again. You see how all our columns are broken, but once we've added back our continuous curve, as seen by here, things go back to normal. And that's the power of Grasshopper actually. If you know what you're doing, if you manage your data well, and you build the logic of your components, well, logically, Things should fall back in place once you fix the problem um, where it started, if that makes sense. But anyway, so we fixed that, and this should also be fixed. So we can now go back here and I don't want to group this because that's temporary, remember. We can regroup that, and we have that settled. So now we have a secondary arc settled, which also have this one. So I want to now extend this a little bit into setting out the secondary arc. We fixed the secondary arc in the setting out here, but now what we want to do is group them in a very nice selectable how do you call it? Selectable groups, let's say, because now we can't really select the secondary arc. Unlike this one, well, I think this one still needs to be trimmed down. Let's do that now, actually. So let's simplify this one, and we can add this to here. If you look at our param viewer, we can now easily select all the columns from the first block, second, and third. I'm going to leave it there for now so we can actually have a look at it. But now we have to do the same for the secondary arcs. Not the columns, mind you, because remember what I just said, the columns are different per level. So we're going to start making the columns in a different video. But in here, the column for the main columns are the same. That's why we have this made. Let's see, how can we select this one? So we need to I think we need to break it. You might think that we already have it right here, which does sound like it's this one, but the thing that's missing from this component is the offsetted curve. Now you might think, okay, then why not we just offset those curves and then we have it also? Well, the problem is not all the curves offset to the right direction. So if I enable the general outline, you can see, for example, that part here offsets to the outside when we want it to offset to the inside. And the same goes for that one, this one, this big one. This one turns out fine, but it could have easily turned out the other way around. So this method it can work if we process this data a bit further using some sort of sorting perhaps. But what I'm going to do is I'm going to actually look for a different way. And I'm actually looking at this because this one is offsetted and all our curves are offset to the right direction already. So what I want to do is I want to actually use this instead and just filter out the ones that we don't need, which are the main arcs. Okay, so that's what we're gonna do. And what I actually need right now, if I can sort of find a way to compare it and then to filter out this curve, perhaps I can use the distance to the curve perhaps from the main curve, since I have points that resides there, and the point resides on the part of the curve that I don't want, right? So that's what we're gonna use. So let's try using that one instead. Okay, that can turn on. That's fine. Let's focus on this one first. Let's explode our curve because there are now 3 curves in total. They're joined together. So let's explode that one so that we have a curve back. And we have points here. What I want to do is ultimately we compare the distance of points closest to each other. And by that logic, I can say the point that's closest to the main arc, which are these points, will be deleted. So that would mean that we also need points on our shattered exploded curve. And I'm going to take the middle point. So now that we have points all over our curve, we can compare them by using the points closest to points component, which are in vector and point. Remember to take the singular one, not the plural one, not this one and not that one. There are 2 differences because the other one has a different a third input, which is the amount of point to look for. But since we only be looking for one, we don't need that one. Let's say P is point to search from. It's going to be those. And the point to search the cloud point is going to be obviously this one. So let's see what we have by digging in a panel. These are the points that are closest. the index of the point, so we can use this to call away our shattered curve. And these are the distance, which I don't think we'll use actually. Yeah, the index is what we want. So if we have the index, we can say call by index. We are going to be calling our exploded curve. So watch what happens if I disable everything. And the index, let's have a last look of our data tree. We have 3 branches. This one has 3 branches. Well, there you go. And we've successfully called away the ones that we don't want, which is the main arc. And if you want to see how they connect, you can actually zoom in here and turn it on. Oh, that's a different one. You actually come in here, turn it on, off. Actually, yeah, that's a different one. But this one does include the straight section, mind you. So there we have our straight section confirmed or extracted along with that one. And now we need to combine these two together in order to create a group that we can easily select. The tree structure of this one is... that makes it simple for us. Let's do a merge. I believe this one is already sorted correctly. Yes, indeed. So if we put this merge in here and another merge in there, because data structure matches, they should all go into the same tree. And if you don't believe me, let's do a tree branch on this one, and we're gonna select. Let's disable everything. And so what I want to see now, if I connect the 0 to the P, is I want to see only the first 2, 4, 6 curves that's belonging to the first block. There we have it. And then the second, and then the third. And that's what we actually want for our setting out later on. And this is the main columns. Well, let's just call it column setting out, to be honest. No, let's just call this one main columns and secondary setting out. Something like that. Something that makes sense to you. It doesn't really matter which one. And let's put this all in a group. Actually, the last thing I might want to do is let's create a curve output from this one. Let me just like that, and this one like here, and then I can actually delete that now, and then I can call these main columns outline, because that's what they are. And this one is secondary columns arc display text, and I want to include everything into that group. Save, and there we have it. We're now basically set to create our real geometry, which are these columns here. So I'm gonna leave it to the next video, and then we will be able to start, well, in a whole different group, and we can actually finally start making geometries, solid geometries. So I'll see you in the next video.